Okay, for Algebra Lesson 5.1, these are your notes. It's all about rate of change and slope. So previously in math, you've learned about rate of change, but let me remind you, it shows the relationship between two changing quantities. Two changing, and we'll talk about how they're changing in just a minute. So two changing quantities. And for our purposes, this could be such as vertical and horizontal. That's supposed to be an and. Horizontal change. So that is exactly what we're talking about today. We're going to talk about vertical change and horizontal change, like if you're thinking about on a graph, if you're thinking about in a table, all of that. So here is a specific story. It's our word problem. It shows the table at the right shows the distance that a band, this is a marching band, a band marches over time. So 1 minute, 2 minutes, 3 minutes, and 4 minutes, they recorded their distance at 260 feet, 520 feet, 780 feet, and 1,040 feet. Is the rate of change in distance with respect to time constant? And what does that rate of change represent? So I first want to give you what we're talking about in the definition up here of rate of change of the changing quantities. So the two changing quantities actually get divided by each other because they get they're put into a ratio. So we're going to do the change in the dependent variable. I'm going to abbreviate dependent, so that's what DEP stands for, divided by the change in the independent variable. All right, we've talked a lot about dependent and independent variables. The independent variable would be the X column, and the dependent variable would be the Y column. So we're talking about the change in what the dependent does goes up here. I know it seems backwards because we usually say this column's second, but in this case, this one is going to go on the top. And then the change in the independent variable, what happens here, actually goes on the bottom. So it flip-flops it. Usually you put the X first and then the Y, but when we're talking about the rate of change and solving it mathematically, you always put the Y on top over the X. And we'll see why you do that in just a minute. So let's calculate the rate of change from one to the next. So if we're talking about how much the change in the dependent variable is, that's over here. So how much does it change from 260 to 520? Well, we're going to have to subtract and see. So let's do 520 minus 260, right, kind of small because I didn't leave you very much room. That is on the top. That's what's changing. It goes from 520 and we need to subtract 260 from it. And that's over, see how we're dividing here, by the independent variable, which the independent variable in this one is from 1 to 2. And I know you guys can do that math in your head. It changes by 1 because it goes up 1 if it goes from 1 to 2. But because we subtracted this one, let's go ahead and subtract the other one. 2 minus 1. Let's see if you can figure out how to do this math. So the change in the dependent variable, when you subtract this, is 260. And the change in the independent variable, when you subtract this, is 1. Okay, we can assume that this is the change every time, but just to be sure, let's go ahead and do maybe one more. So let's do 780 minus 520. This is how we're determining whether or not it's constant. And from 2 to 3, so 3 minus 2. 780 minus 520 is also 260. 3 minus 2 is also 1. So we're assuming this is constant, and since I'm doing the work and you don't really have to on this one, let me go ahead and just subtract the last one here. 4 minus 3. This is also interesting, going to be 260 over 1. So yes, it is constant. It asks up here, is it constant? Yes. And then what is the rate of change equal? Well, it's 260 per 1. 260 per 1, 260 per 1. So in math, anytime 1 is on the bottom, you can just call it the top number. So it is 260. But what does that mean? What does that represent in this story about marching band? So you will need to hopefully understand that what it means is the band marches 260 feet per each 1 minute. Okay, and hopefully that makes sense to you. So even though they went from 260 to 520, that was still 260 feet per minute. And then they went up to 780, which was another 260 per minute. And then they went up to 1040, which was another 260 per 1 minute. So it is constant at 260. So the band marches 260 feet per each 1 minute, per minute. I guess that's kind of redundant there. All right, then they graphed it for you. I didn't make you guys make a graph. Thank you very much. So at 1 minute, they had gone 260. At 2 minutes, they had gone 520. At 3 minutes, they had gone 780. And then at 4 minutes, they'd gone 1040. So they've got all these graphs on here. And it's a straight line because it's constant. It's constantly going up and over at the same amount. So what is the up and over that it is changing by? It is going up 260 per every 1 minute. So up 260 per over 1 minute. And here's what I want you guys to note. The rise is how much it goes on the vertical axis. So this is our vertical change. So vertical change, and that always is the dependent variable, so that goes over the independent variable, which is the horizontal change. So the reason I'm writing this down is because I'm getting ready to make it into much smaller words. If you're rising vertically, you are rising. So I'm going to call the vertical change my rise. And I'm going to call the horizontal change, which is when you go from left to right, my run. Because to me that makes more sense. Your rise and then your run. So it goes up and over, and it would keep going up and over at that same constant rate this entire line. I could keep going. I mean, just because they only stopped at this many minutes, I could have gone down to 100 minutes if the band was still walking, and it would still be going rising and running at a constant rate of 260 per minute. So the vertical change is the rise, the horizontal change is the run between 2 points, any 2 points, up and over at the same amount, 260 per 1, 260 per 1, 260 per 1. So that is considered our slope. How steep this line is based on how much it rises and how much it runs each time that you could put another dot on the line is called our slope. So in easier words, you know what, I'm just going to rewrite all this. So it's the vertical change over the horizontal change. Okay, and even easier than that, it is the rise over the run. We are always going to just say, what's the rise, what's the run, what's the rise, what's the run, and it should be constant every time if the line is straight. All right, so now we're going to find it from graphs. Find your 2 points. If there aren't 2 points on the line, you're just going to have to pick 2 points. So here are 2 points, and we are going to count how far do we rise and how far do we run in order to put those two numbers in a fraction. So we rise 1, 2, and we run 1, 2, 3, 4, 5. So it looks like a fraction 5 over 2, but rise goes on top, run goes on bottom. So it's actually 2/5. So the slope from a graph is how far do we rise over how far do we run. Okay, something interesting in a line that's going downhill. So do you see that you'll read graphs from left to right? From left to right, this one's going uphill. If you can think about a stock market, this is good, 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 it's going up. But from left to right, this graph is actually falling. It's like a stock market that's falling. This is bad. So this is going to be negative. So before I even count my rise over run, I want to put a negative off to the side because I know this is going to be negative because I can tell that my slope is going downhill as you read it from left to right. So pick 2 points, and you're still doing rise over run, but that to me is kind of backwards. So I'm going to do fall over run. Like instead of rising, we're kind of falling, and I'm hoping that that will remind you that it's a negative. Anytime you count down first and then over, it's probably because it's going downhill, so that reminds you to add your negative. So we're going down 2 per every over 1, 2, 3, 4, 5, 6. So negative 2/6. Also, anytime you have a fraction that can be simplified, please do it. Negative 2/6, both divide evenly by 2, which would make it negative 1/3. And you can check it, because even though it's 2/6, it still should work for 1/3. If you go down only 1 and over 1, 2, 3, it should still be on your line. And it is. So you can either count down 2/6 or down 1/3, and it will keep going at that rate the whole way. All right, your next key concept is learning the slope formula. This is a big lesson. There's a lot of stuff in here. So let's say I don't give you a graph. I'm going to hide my graphs. All I'm going to give you is 2 coordinates. And I'm going to say, okay, what's the slope of this? Well, a lot of people might say, well, give me a graph so I can put the dots so I can count rise over run. Well, I'm not giving you the graphs. So in order to do this, you need to know the slope formula. And the slope formula is y2 minus y1 divided by x2 minus x1. Now you may be like, what in the world? But we've actually already done this up here. We took 2 of the change in the dependent variables and subtracted them, and 2 in the independent variables and subtracted them to get our slope. So we've actually already done this. I just didn't label it as y2 minus y1 over x2 minus x1. If you're looking at your coordinates, you know this one is x and this one is y, hopefully. You know this one is x and this one is y. But what you may not have realized is that your first set of coordinates are your 1s, because they're the first ones, and your second set of coordinates are the 2s, because they are your second ones. So when you subtract, you're going to take your last one and subtract your other one. You're going to subtract the 2 y's. So y2 minus y1, so negative 2 minus 0. So I'm just going to plug in negative 2 minus 0 over x2 minus x1. So over x2, which is 3, minus x1, which is negative 1. So 3 minus negative 1. Yes, you have to put both in there because it's the formula is minus and this one was a negative. So, I mean, technically this should be in parentheses, but I don't care if you don't show that, as long as you know what it means when you have a subtracting a negative. So negative 2 minus 0 is just negative 2. 3 minus negative 1, put it in your calculator if you're not sure, it's 4. So the slope of these two, without looking at a graph, is negative 2/4. And yes, I told you we're going to simplify, so simplify. Negative half is the same thing as negative 2/4. Okay, push pause and try this next one on your own based on using the slope formula, if you can. If not, I'm going to work it out right now. All right, we're going to take our last y and subtract our first y. So negative 1 minus 3. And we're going to take 4 minus 1, which are our x's. Negative 1 minus 3 more is negative 4. 4 minus 1 is 3. And so negative 4/3 is your answer. A lot of kids might have wanted to make it, since this is improper, might wanted to have made it into a mixed number like negative 1 1/3. I don't want you to do that. And the reason is because if I said, what is the slope of this line, and you said 1 1/3, I don't know how many that's going up and over. I only want 2 numbers. How many do I go up and how many do I go over? Or in this case, how many would I go down and how many would I go over? So if you change it to a mixed number, that's confusing. So even though it's improper, just leave it, because I could put that on a graph and it makes sense. All right, flip it over to the back. This is a lot, I know. All right, horizontal and vertical lines are kind of funny. They're different. If you have a horizontal line, if you were skiing in Colorado and you went to get on a slope that was this steep, and you said, well, give me a number that would represent this steepness, I hope you would think 0. And that's true. That is true. A horizontal line always has a slope of 0. So horizontal lines represent 0. Vertical lines, if you were to get on a slope and go skiing here, that is impossible to calculate. It's too difficult. We can't even mathematically put a number on this. So we are going to call a vertical line undefined. It is not able to be defined. So a horizontal line is always 0, and a vertical line is always going to be called undefined. Let's try to calculate a few of these. So 2 minus -3, using the slope formula, 4 minus 4, and we're going to divide, changing the y's over changing the x's. So 2 minus -3 is +5. 4 minus 4 is 0. Have you ever put in a number divided by 0 into your calculator? If you haven't, you should try this now. So 5 divided by 0. Your calculator should say error. Divide by 0 error or some type of error. And the reason is because it is impossible to divide by 0. It's not calculatable. So that would be the same equivalent answer of undefined. And if you just wanted to check this to make sure you did it right, think about what these two ordered pairs would be on a graph. 4, -3 would be like down here-ish, and 4, 2 would be like here-ish, which would make a vertical line, which is undefined. Okay? All right, let's try B. -3 minus -3 over 5 minus -1. There's a lot of negatives here. All right, -3 minus -3. Put in your calculator if you're not sure, but it is 0. And then 5 minus -1 should be 6. Have you ever divided 0 divided by a number? Let's try it. 0, oops, that's not right. 0 divided by 6 is 0. So 0 does work in math when it's on top, when it's the first number that we divide with. So 0 divided by 6 actually is 0. And again, if you did my little checking with these trick on a graph, -1, -3 would be around here-ish, and 5, -3 would be around here. So that would be a horizontal line, which we already talked about up here. Horizontal lines have a 0 steepness on the slope. So please know the difference of when you are dividing by 0, it's undefined, and when it's 0 divided by any number, it is 0. And if you're not sure, just put it in your calculator or do a quick sketch and see what it would be. In class, we're going to watch The Adventures of Slope Dude. If you are at home and haven't seen this, it's worth YouTubing. It's pretty hilarious. I love to watch The Adventures of Slope Dude. It's super old school, so it's funny. But here's what Slope Dude teaches you. It teaches you the 4 types of slopes. So if a slope from left to right, you always read a line from left to right, just like you do a book. So from left to right, if it's going uphill, it is positive. If it is going downhill from left to right, don't forget that negative symbol. It's negative. If it is horizontal, it's a 0. And if it is vertical, it's undefined. All right, so watch Slope Dude if you can. If not, here's all Slope Dude teaches you right there. All right, for the last section, it's a you try. So I would love to see you guys try these 5 questions on your own and then push pause in the video and then come back to it and see if you got them all right. If not, and you'd like to try it with me, I'm gonna work it out with you as well. So push pause now if you'd like to try. All right, I will work this out with you if you need me to, or if you just wanted to see if you did this right. Is the rate of change constant with number of pencils bought? So I would do, remember y's are on top, subtract your y's. So I'm gonna do 1 minus 0.25 on top over 4 minus 1 on bottom, because y's are always on top, x's on bottom when you subtract. So if I have $1 and I subtract 25 cents, that's 75 cents. 4 minus 1 is 3. And I know that this is not simplified, but it can be. 75 cents per 3 pencils divides out to be 0.25 per 1. So explain what it means. It means that 25 cents is how much it costs for each 1 pencil. Okay, oh, and is it constant? This changes by 0.75, this changes by 0.75, this changes by 3. Oh, that's way more than 0.75. 12 divided by 3 is 4 though, so actually they skip some numbers in here, but this actually is still constant, so yes. All right, number 2, what is the slope of the line? I hope you saw it was going downhill. So you put a negative right there. And how many is it falling per how many does it run instead of rise over run? It falls 1 and runs 1, 2, 3, 4, 5. So it's down 1 per every over 5. So negative 1/5 is the correct answer. Number 3, you're using your slope formula, y2 minus y1 over x2 minus x1. So negative 3 minus 2 over 2 minus negative 1. That would be negative 5 over 2 minus negative 1 is positive 3. And we're just going to leave it improper. Just leave it improper. It's okay that it's improper. Just leave it. Number 4, give an example of a real world situation that you could model with a horizontal line. So this would mean maybe over time, distance over time, like if this is time and this is distance on a graph. Maybe you started to go to your friend's house and you walked how far away, but then once you got to your friend's house, you hung out there. So a horizontal line might represent time of not going any distance, and then maybe you walked back home. So a horizontal line could represent, and this is just one explanation. Obviously, there are a ton of different answers possible on this, but it could represent time spent in one location. And again, this only works in my specific example of time per distance. Sorry, distance per time. Okay, and then the last one, error analysis. A student calculated that the slope of this line was 2. Explain the mistake. Well, if I do rise over run, I see it's up 1 over 2, so it should be 1 over 2. It looks to me like the student maybe did 2 over 1, and 2 over 1 actually would simplify to just 2. So I think the student flip-flopped the rise over run. So they, I'll just put flip-flopped. They accidentally flip-flopped the rise and run. And then it should be 1/2. It says, what is the correct slope? The correct slope was up 1 over 2. So 1/2 is the correct answer on that one.